If each day is only 23 hours 56 minutes 4 seconds, over the course of 4 years, we accumulate 95.7 hours of unaccounted time when approximating each day to 24 hours. We give ourselves one extra day in February, which accounts for only 24 hours of that extra time. But where does that extra 71.7 hours go? I'd like to congratulate you. You took the base data, calculated the difference and came up with a reasonable question. You were missing one variable, sidereal time, and you sought an explanation as to the variance of theory with observed data. You learned, others learned. Science and logic FTW. Earth actually rotates around its axis 3.56 minutes less than 24 hours. If we would not be adding 3.56 minutes to get a 24 hours day, for everyday demand to get sun on its exact spot on every high noon, we would have on 21 December high noon sun on exact midnight hours, and or vice versa. Aside from your math being off and confusing solar and sidereal days, an extra day every 4 Februaries is not the only corrective measure we use. There are also leap seconds which are applied when needed, and also century years are not leap years unless they are divisible by 400. 2000 was a leap year, but 1900 wasn't and 2100 won't be. 23 hours 56 minutes 4 seconds is the length of a sidereal day, which is how long it takes the Earth to rotate once relative to faraway stars. For our calendars, however, it is much more convenient to go by our rotation relative to the Sun. This type of measurement is called a solar day. Going by the solar day, the calendar is off by about 1 day every 4 years, which is why we have leap years. 1 year is one rotation around the Sun and not calculated by 360 degrees rotation time. Earth completes one trip around the Sun in 365 days, 5 hours, 48 minutes and 47 seconds. 23 hours and 56 minutes day called sidereal day, aka 360 degrees turn. 24 hours day is considered 361 degrees turn. 1 degree is gotten from Earth movement in space, as far as I know, feel free to correct me. If the Earth orbits the Sun in an elliptical orbit and the South Pole is farther away from the Sun in the winter, trying to remember 6th grade science, will the orbit change ever so slightly that over time so that the North Pole will become farther away from the Sun in the winter? As years go by, would it make sense to change what we call a second so that the time difference doesn't change how we experience life? Make it shorter if the years are going by faster. I think serious studies would have to go into this before it were introduced. Could create a lot of different kind of problems changing everyone's internal clocks like that. I am curious as to you reached 95.7 hours. It should only come out to about 22.7 hours. Each year being adding about 5.7 years.